So far we have done 2 scenarios, and we're going to start the third scenario, which is deploy Guestbook web app example. So this scenario explains how to launch a simple multi-tier web application using Kubernetes and Docker. The Guestbook example application stores notes on guests in Redis via JavaScript API calls. Redis contains a master for storage and a replicated set of Redis slaves. So the following core concepts will be covered during this scenario. There are the foundations of understanding Kubernetes, pods, replication controllers, services, notebooks. So let's start the scenario. Deploy Guestbook example on Kubernetes. Step 1 is start Kubernetes. To start, we need a running Kubernetes cluster. The result of this is explaining launch Kubernetes cluster scenario. So first starts a single node cluster using the helper script. The helper script will launch the API, a master, proxy, and DNS discovery. The web app uses DNS discovery to find the ready slave to store data. So let's launch search. So check everything is up using the health check. We are using this health check. Okay, so there's our okay. Can move to the second step. Redis master. The first stage of launching the application is to start the Redis master. A Kubernetes service deployment has at least two parts: a replication controller and a service. Replication control defines how many instances should be running, the Docker image to use, and a name to identify the service. Additional options can be utilized for configuration and discovery. Use the editor. We are using this editor to view the YAML definition. Yeah, we'll create a replication controller. So it is created. If you want to see what's running, the command we are using is this. So container is described as pods. A pod is a collection of containers that makes a particular application. For example, Redis. If you want, we can view this using kubectl. Okay, we can move to the next one. Redis master service. The second part is a service. Kubernetes service is a named load balancer that proxies traffic to one or more containers. The proxies works even if the containers are different nodes. Services proxy communicate within the cluster and rarely expose ports to an outside interface. When you launch a service, it looks like you cannot connect using curl or netcat unless you start it as part of Kubernetes. The recommended approach is to have a load balancer service to handle external communication. We create the service and then list first of all the list and then discover services. With that, we can move to the fourth step, which is replication pods. So this example will be running Redis slaves in which we'll have replicated data from the master. More details if you want you can find using this given URL. As previously described, the controller defines how the service runs. This example means determine how the service discovers the other pods. So we start Redis slave controller using the command. is created. If you want to get a list, you can use this kubectl get rc. With that, move to the next step, which is 5. Redis slave service. As before, we need to make our slave accessible to incoming requests. This is done by starting a service which knows how to communicate with Redis slave. So we'll start it, and then you can view. So move to the next step with which is front-end replicated pods with the data services started. We can now deploy the web application. The pattern of deployment web application is the same as the pods we deployed before. So we launch front-end, and then we'll list the controllers and pods. Front-end is also there. Again, here the front-end is there. The PHP code uses HTTP and JSON to communicate with Redis. Inserting a value requestable to Redis master, read data comes from Redis slave. Okay, step 7 is Guestbook front-end service. To make the front-end accessible, we need to start a service to configure the proxy. So we'll start the proxy. Let's see if all the details are there. Okay. Then we can go to the last step, which is access Guestbook frontend with all controllers and services. Define Kubernetes. We start launching them as pods. Pod can have different states depending on what's happening. For example, if Docker image is still being downloaded, then the pod will have a pending state as it's not able to launch. Okay, so we'll view the pod status. kubectl get pods running, all the features are there. If you want to find node pods, if you didn't assign a node port, then Kubernetes will assign an available port randomly. You can find the assigned port using kubectl. If you want to use the UI, so once the pod is running, then you will be able to use the UI for the ports. So you can see that it's working. So under the covers the PHP service, discovering the Redis instance via DNS in a working multi application for Kubernetes. So that's all for this scenario. Can move to the next one.